All right, so we have 34 through 36. It says describe the end behavior, determine if it's even, odd, and then state the number of real zeros. So it's odd if the graphs end in opposite direction. It's even if the graphs end in the same direction. And then the end behavior is where you have x going to infinity and negative infinity. And then you describe what the y values are doing. The degree is always one more than the number of mins and or maxes. So in this case, you have 1, 2, 3, 4 mins and maxes. The 34 is a degree 5. So it's the degree is one more than the number of mins and maxes. The number of roots, if it's odd, will always be odd. The number of roots, if it's even, will always be even. So you can see here you have 4 real zeros. That's an even number, and that's an even function. We have 2 zeros. It's an even function, even number of zeros. Okay, 37, 38, and 39. Okay, and then I know your 57 to 60 are a little bit smushier. But there's 57. So these are at the bottom of your page. Mine are just a little bit more spaced out. Okay, and then 60 to 62. Any questions or concerns on the first part of 6.3? Is everybody okay with how to determine even, odd, positive, negative, and end behavior? Alrighty. And then the second part of 6.3 is function notation. So that's where you are taking a function, you're plugging it in, and finding a value. So here's the top part of that worksheet, so 7 through 12. All right, and then the bottom half. So 13 to 18. Any questions or concerns on finding a function by plugging in a function? And then at the top of the next page, again, if you have P of a number, then you get a number answer. If you have a function, then you get a function answer. So in that top half, you are plugging in a number, so you're going to get a numerical answer. And then in the bottom half, you're plugging in a function, so you're going to get a function answer. Okay, and then there's 27, 28. So here's 30. And again, I just wanted to go through a couple of these with you. So, because I think these were the ones that were giving us a little more trouble. So if you have a function, it just replaces all of the x variables. If there's a number in front that distributes after you replace all of the x's. So like in 31, you have b squared, nothing in front. So then you take the x's in c and replace them with b squared. So it would be like 2b squared. Now there's a square in the problem, so that square remains. Minus 4 times b squared plus 3. So something squared gets multiplied. So you get 2b to the 4th minus 4b squared plus 3. And then similarly down here, that 4a squared goes in for every x. So it would be negative 4a squared cubed, where the negative is outside the cube, plus 4a squared plus 1. So that cube is going to go both to the 4 and to the a. So it will be negative, and 4 cubed is 64. 2 times 3 is 6. So you get negative 64 a to the 6th, and then plus 4a squared plus 1. And then here, this entire function goes in for your variable. So it's negative 4y minus 3 cubed plus 4y minus 3 plus 1. Now if that's cubed, that's like our multiplying and multiplying. So you have to actually take negative 4y minus 3 times 4y minus 3 times 4y minus 3. And then you can group together your like terms at the end, so plus 4y minus 2. But you have to multiply these in sets of 2. So you'd have negative 4 times 4 is 16y squared. 3 times 4 is 12y, and you do that twice. So you get negative 24y plus 9. But then we have to distribute that with the 4y minus 3 again. So 16 times 4 is going to give you a negative 64. And again, you can leave that negative here, or you can distribute it in. If you leave it out one last time, you get 4 times 16, which again is 64y cubed. 4 times 24, which is negative 96y squared. And then 4 times 9, which is 36y. And then you have to distribute the negative 3 as well. So you get negative 48y squared. Negative 3 times negative 24 is going to give you a positive 72y. And then a negative 27. And tag on that 4y minus 2. Combine like terms, distribute your negative. So you get negative 64y cubed. And then combining like terms in here, you get negative 144y squared, but you distribute the negative, so you get a positive 144y squared. And then you have 36y and 72y, so that is 104y. Distributing the negative becomes negative 104y. And then you have negative 27. And then distributing your negative became positive 27. But adding the negative 2 to that, you get positive 25. So there's our final answer for 33. So hopefully that helps for anybody, because that's pretty much a combination of everything we did. That takes you back to lesson 6.1, where you were looking at multiplying and dividing and adding and subtracting, all of those like terms. And then in 34, your final answer is 2y to the 4th minus 8y squared plus 9. Are there any other problems, because I didn't show work for all of them, that you wanted to see from that review? Feeling pretty good? Okay. So then what I want to do today is I have a review handout for you. We'll work on this today, go over it tomorrow, and then tomorrow we're going to play a review game. And we'll vote on that review game now. So if you like bingo, I have a bingo review game. Or if you like our more competitive Jeopardy, with like the board passing around, I have Jeopardy. So, if you want bingo, raise your hand. 1+1. Okay? So, like Jeopardy? Yeah, I was surprised. I thought, alright. I thought for sure we were picking bingo. Like,
I don't like Jeopardy. It's a little too competitive. They take it too seriously.
Cool.
They
That's
do,
right.
but like I also like Jeopardy at the same time. Most people in this class take it too seriously, so it takes all the fun out of it. Literally.
Singular person.
Well, there's like a couple other ones, but like.
I think so. Are you really?
I like the socks.
I thought, like, for me, it doesn't matter.
I like the
made.
socks.
Like, I
I
played
have
those in
some
the
socks
past,
like
so
that
I
too.
really just,
But I like
I need to print you, like, the boards we
I
play
have
on, so
practice
that's why.
socks.
So we'll pick today.
But you make them more fun.
Is there something wrong with generic?
She's ripping on my IHOP socks.
I'm not ripping on her eye.
My cousin did it.
Alright, guys, so, we'll use the rest of class time to go through this. If you're looking at either any of those pages right now, is there, oops, I give you an extra. Thanks, Tessa. Is there anything on there that you're like, oh my gosh, I completely forget, like, how to do that? Or if you're working on a problem and you're like, hey, Miss McBride, can you do that problem? Like, I'm sitting back here, I can gladly go over any of them. There's already a Dropbox for this homework assignment on Fusion. So once you've worked through it, you can just post your answers for me so I can give you your credit for that. So it's kind of like your in-class / homework.